Can you hear me all right?
There you go for it.
Okay. All right, well, welcome everybody to this week's installment of the Interface Engineering High Performance Buildings free webinar series. For those of you that have been to our other sessions, welcome back. And for those of you that have not, well, welcome for the first time. Just a brief introduction. This is a series presented by Interface Engineering. My name is Roger Frechette. I'm the managing principal with Interface. Interface is a 51-year-old mechanical, electrical, plumbing, fire protection design firm. We have offices around the country, including one right downtown Washington, D.C. that we're eager to get back to and start working in again someday. But today we have a very special session for you, a discussion on stormwater and reclaim and reuse. And it is my privilege to be able to introduce today's speaker, Kevin Cahill. Kevin Cahill is a friend of mine. Kevin and I have worked together for probably about 25 years now. But Kevin is a senior engineer. He's a principal in our Washington, D.C. office. Kevin received his bachelor's degree from Worcester Polytechnic Institute, WPI. He's a licensed professional engineer in the District of Columbia. He's certified in plumbing design and a LEED accredited professional. Several years ago, Kevin was awarded the 40 Under 40 award from Consulting Specifying Engineers. And Kevin's experience really crosses a very wide range of project types, everything from schools to multifamily to commercial office building, very tall buildings, very short buildings, healthcare. But like the other engineers in our office, we have a keen focus and specialty when it comes to high performing buildings, low energy buildings, net zero energy buildings, net zero water buildings. And that's really the focus of this particular series, this particular webinar series. So again, I'd like to turn it over to Kevin Cahill to take us through the presentation. Take it away, Kevin.
Fantastic. Thank you, Roger. I'll let you be my promotion guy any day of the week. Thank you for the intro. I appreciate that. Welcome, everyone. Feel free, quick housekeeping, feel free to use the questions and chat tab that you see in the GoToWebinar. If nothing else, if you hear a joke you like, send a thumbs up or smile or something so I know you can hear me out there. A little different these days, having to do things virtually. But post your questions there as well, and we'll get to questions at the end. You don't have to write anything down. We will make this presentation available to you. So any of the links you see or websites or even the values and references in the presentation will be made available. So you don't have to scramble and write any of that down. So I'd like to step you through today, stormwater reclaim and reuse. Stormwater reclaim, also called rainwater harvesting, depending on what your jurisdiction is and where you're from. We'll give you an overview. I assume most of you are here because you already realize that water is a precious resource throughout the globe. So really, we're not focused so much today on potable water as much as we are saving potable water and capturing stormwater for reuse. The course is AIA accredited, so I have to go through your learning objectives here. We're going to talk a little bit about the history of stormwater and reuse. We're going to learn about the regulatory requirements for stormwater capture and reuse and where those apply and where they do not. We'll learn about some calculations and how we perform to determine our water balance. That's both for collection and for reuse. And I'll show you some tools that we use internally. And then last, we'll learn about some different kinds of systems and the application of the treatment itself that allows for the water reclamation and the reuse. So this is our table of contents. This is a little bit of a regurgitation of our learning objectives. the history of water, regulatory requirements, water balance calculations, application considerations, and then questions and answers. So as a water resource, just backing up a little bit, 2/3 of the surface of the earth is covered by water, which sounds great. The challenge with that is this: if all the water were to fit into a 1-gallon jug, the amount of actual fresh water available is just over a tablespoon. So less than half of 1% of the water in the world is actually potable, or actually drinkable. So we recognize that all the water you receive and drink is manufactured, frankly, and it's costly, and is a resource that is becoming more and more expensive. And you don't have to look too far in the news. You can go back as early as 60 Minutes, I think last weekend, talking about the water quality in New Jersey. And of course, everybody remembers the water quality issues of Flint, Michigan, just a handful of years ago. The idea here, as part of, we're not going to talk about that water quality problem. What the idea here is we're going to talk about reducing our need for that water quality. One of the major issues with municipalities is their treatment of that water, and they have to treat more and more of it on a regular basis. And to that end, there's approximately 1 million miles of pipelines and aqueducts that carry water in the US and Canada, enough piping to circle the earth 40 times. So there's a lot of infrastructure out there. There's failing infrastructure out there in potable water. So as we put more demand on potable water, we put more demand on those systems. So the idea of stormwater capture and reuse is to put less demand on those resources and hopefully allow them to make improvements to those so that when you truly do want potable water out of your kitchen sink, that you can get that resource.
Hey, Kevin, a quick interruption. The slides don't appear to be advancing. So I don't know, Emily, if you're on the line, maybe you could help us with the visual portion.
What did I do? They're not advancing.
No, I think everybody is still seeing the cover slide.
I don't know why that would be. Uh-oh. I'm sharing my screen for a moment. Is that better? Can you see the course description now?
Yes, back in business.
Is that learning objectives?
Yes.
There we go. Okay. Better? My apologies. They weren't very pretty slides anyway. Are we at stormwater management now, Roger?
Yes.
Oh, I'm sorry. Sorry, everyone. Okay. So we're going to take, back to the show. So for stormwater management, as many people know, in the Washington, D.C. area, Washington, D.C., Maryland, Virginia, there are stormwater management regulations. So in 2013, in Washington, D.C., anybody that had major land disturbing activities, what was required for new projects was required to retain 1.2 inches of that storm event on their site. And for major renovations, it was 0.8 inches of retention for that storm event. So just recently, literally the last 6-7 years, there's a requirement locally in the district to retain stormwater on site. So many of your projects, you'll see cisterns either inside or outside your building that are meant to detain and retain stormwater. One of the biggest deterrents in the past to stormwater reclaim and reuse has been the cost of that initial storage. Well, now in many jurisdictions, that cost is a sunk cost. It's a requirement by the local jurisdiction. So it is the case that Maryland and Virginia have very similar requirements for stormwater manuals, stormwater issues for, again, treatment. A lot of it's quality issues, but anytime there's a detention component, that's generally for us a green light to seriously consider stormwater reclaim and reuse, since so much of the cost of the tank itself is already incorporated. So I don't pretend to be the stormwater management expert. However, I will tell you, you can buy this t-shirt online. You should be nice to your civil engineers. So at the beginning of a project, the civil engineers are generally doing the stormwater management for your site plan and site plan approvals. They will know the rules and regulations, and they do the calculations to determine exactly how much detention needs to be performed on site, retention or detention. So, and this applies in California, Oregon. We're doing a project in Pennsylvania right now that we have a large detention tank as well. So be nice to your civil engineers, work with them early, determine if you need that, if they have a stormwater tank already. And once you have that, to me, that's a green light to have a real discussion on stormwater reuse. Now, you can certainly still do stormwater reuse even if you do not have a jurisdiction that requires you to do detention on site or you need to be a little bit careful on water reuse. So one thing you need to do is make sure you understand the jurisdiction you're working in and that they allow you to reuse water and what they allow you to reuse water for. So we're fortunate here locally, Maryland, Virginia, Washington, D.C., they allow us to use stormwater and to capture and reuse that water for different purposes. There are absolutely states that do not allow it at all, and there are states that have recently changed. So we did a project quite some time ago in Colorado, and in Colorado back in the day, you could not do stormwater capture and reuse. The idea there used to be that the stormwater that hit your site, you didn't own it, and you weren't required to capture it or do anything. In fact, they believed that the water that hit your site was valuable to run downstream and irrigate future or further farms that are downstream of you. Now, recently they've changed their rules, it looks like, in 2016, and they do allow capture, and they're allowing it for irrigation and gardening. So still restrictive. So there's a website link here at the bottom. It's a pretty good resource. It was updated as of June 12th, and it's indicating whatever state, it's a good place to start, I would say, to go to your state's websites and determine what state are you in, and do they allow you to capture stormwater, and what do they allow you to do with it. So if you followed back through even the Virginia guidelines, the Virginia guidelines will not let you capture stormwater and reuse it for potable water, but they do let you capture it and reuse it for non-potable sources, flushing fixtures, cooling tower makeup, irrigation, etc. So those are the first two major steps, I think, in the process of stormwater capture and reuse. Is what's your civil engineer doing? And do they have a large cistern already, whether that's inside or outside the building, preferably outside? And then what is your state restrictions on the capture and reuse? And nearly every state has a policy on stormwater harvesting and stormwater reuse. The rainwater harvesting guide in Oregon has been available for quite some time. I remember doing a stormwater reclaim system back in the early 2000s, and they had a stormwater guide and a rainwater harvesting guide in Oregon back then. Nearly every state that allows it has different standards developed. Virginia has one, Maryland has one. In many cases, they're referring to what you see on the right, which is the EPA document for rainwater harvesting policies. Also a good document to read to understand sort of the genesis of the guidelines being developed by the states. So what you see on the right is really the EPA's policy to try and help municipalities write their own guidelines. A lot of times you'll hear about a purple pipe system, and as the non-potable water source, as the reclaimed water that people are using. The reason for that is in 1992, the EPA has a document that is for stormwater, or not stormwater, but it's for secondary use or secondary or reclaimed water. And in there, it required you to paint your piping magenta. So that's the genesis of where those code requirements came from. And these days, what you'll find is not only the state will have a guideline on harvesting and reuse, but the plumbing codes now have adopted requirements as well. And in there is that requirement to indicate that your piping is purple. So you'll hear purple pipe a lot, but that's really where it came from back in the 90s. And then what they're really trying to do is label your piping in the building so nobody cross connects or missteps and connects to the wrong pipe. So now we're going to talk about the calculating of rainwater and reuse. So within the calculations, we do it in a couple ways. This is an overview of how we do it with integrated design. And we're talking about the uses of rainwater and the basic formula at the bottom. The basic formula at the bottom, what that's telling you is how to really convert from square footage of your roof times 1 inch of rainfall in order to get gallons. So in Washington, D.C., you would multiply this by 3.2 inches, and that's going to get you roughly 2,000 gallons. And that's about 2,000 gallons of water for a design event in Washington, D.C. So, and that's per 1,000 square feet. The other way to look at this is in Washington, D.C., if you have to capture that first 1.2 inches of water, what that's really telling you is that that first 1.2 inches, for every 1,000 square feet you have, you need whatever 623 times 1.2 is. You need about 700 gallons or so, 725, I think, to capture, or that's the volume per 1,000 square feet. So that's a very large number, as you can imagine, when you start working on buildings that are 20, 30, 40, 50,000 square feet of footprint in Washington, D.C. So the place we start when we do our stormwater calculations is the rainfall data, the history of the rainfall in the area or the jurisdiction you're in. This happens to be Portland, Oregon. This is the rainfall data for the last 50 years. If you go to NOAA's website, you can download the historical rainfall daily data for a year. It's giving you the average number for every single day of the year, and that's the number we use. So we're collecting that number so that we can look at daily rainfall rates, average daily rainfall rates, average monthly rainfall rates, and ultimately the annual number. The annual number, when we get into stormwater, isn't quite as critical. You know, when you talk about net zero energy or net zero buildings, it's always based on an annual basis. That's not the case for water, because if you look at an annual calculation, you may, and this has happened locally here in Washington, D.C. on other projects, you may end up with a storage tank that is far too big and it's far too useless because you can't get the water out of the tank if the volume of the tank is too large. In other words, if you had 1 inch of water at the bottom of the tank, you can't actually get it out. So we look at the daily average rainfall rate for as many years as we can get, the daily average. So that's where we start. This is our calculation sheet. I'm going to skip this for you, just let you know it's very complex and complicated. And it looks at a whole host of things that are black water, gray water, the volumes in tanks, the volumes over time, combined sewer systems, etc. So I've broken this down to make it a little simpler for purposes of today. So really what we do is once we have the rainfall data and we know the average per day, we're looking at where are we capturing, where are we collecting stormwater from or rainwater from. So in this case, we're looking at 3 different areas. We were looking at collecting it from a roof. We were looking at connecting it. Let's see if I can get my a roof, a green roof, and a field. And in this case, this field happened to be an AstroTurf field. One of the multipliers we have to use for stormwater capture is the runoff coefficient. So you can imagine if you put a drop of water on a piece of glass that was sloping, the runoff coefficient on that piece of glass might be 0.99. Most of that water would run off. When you look at a roof, most roof systems, your runoff coefficient is 0.95. Green roofs, it's more like 0.4. And it really does depend on the type of green roof. So your civil engineers, again, will ask you when they're doing their calculations, do you have an extensive roof, an intensive roof? How deep is the soil? What is the planted material? The reason they want to know all of that, whether they tell you or not, I don't know. The reason they tell you that is they need to also know what that runoff coefficient is. That runoff coefficient, depending on what you select, could be as high as 0.6, meaning 60% of the water goes through. You can get them as low as 0.2, meaning that it's capturing 80% of that water, that is holding that water already. So that's what's helping you in a lot of projects to minimize or reduce your detention and retention at the lower levels. So this is a multiplier we use, and again, we take this area by this coefficient by the daily number. That's how we know how much water we can get on any individual day, month, or year. So then we look at where can we reuse the water. Now, again, you need to be careful with the jurisdictions you're in and make sure that you're allowed to use the water for flushing. In our case, for this example, we are reusing the water for flushing, and we're reusing it for cooling towers. So the calculation for water reuse for toilet flushing, one of the best calculators out there, frankly, is the LEED calculator. It gives you a great baseline number for minimally code compliant fixtures. It gives you a great design number based on the flow of your fixtures themselves. A lot of times we'll use the LEED calculator. This happens to just be a summary of what it might look like, where it's the number of people, the number of uses per day, and what your gallons per flush are. And what that's giving us is our gallons per day. Now, I mentioned earlier that we do the daily rainfall. The reason we do the daily rainfall is because of the building types. So if we're a commercial office building, for example, this toilet flushing number reduces substantially on Saturdays and Sundays. If we're a K through 12 school or a high school, that number changes on weekends. So this is why we don't like to look at an annual number. We definitely like to look at the daily, weekly, monthly, so that you can take a look at how much water you can store and use. The other thing we look at is cooling tower makeup. You'll see cooling tower makeup for this project, where the gallons per day is through the roof compared to our gallons per day for flushing fixtures. So, and it depends on your climate. You've got to work with your HVAC engineer. Generally, we get this number out of our energy models, or we can get it out of our load calculations, but we look at cycles of concentration and evaporation, blow down and drift for the mechanical engineers out there, and how much water needs to be made up. In this case, I'm showing it to you in total per month, but it's a very, very big number, generally speaking, when you compare this to the flushing number. So this is a snip from our calculation that we do. You'll see in the upper left, we're looking at the water sources. And in this case, we're focused on what's in green in the water sources, which is stormwater and condensate. Both of those are combined in most buildings. Our calculation also factors in cooling tower blowdown, gray water, black water, and the municipal supply. For purposes of today, we can ignore the gray water and black water portion and focus just on the stormwater piece. And then in the middle of the diagram, you'll see where we can use that water. It's in the upper right as well, where we use it for landscape, cooling tower makeup, toilet flushing, and other. In the case of other, we have in the past and in current projects used stormwater as makeup water to fire water tanks. A slightly more complicated design, so when you take out of that fire water tank, you have to make sure that you always maintain the minimum code requirement for volume, that you're leaving that behind for fire life safety. So this is a diagram of the calculation that we use. This is the reuse demand versus supply. So you'll see that that sort of yellow line happens to be our reuse number, and you'll see what's in blue is the supply that we can get from the cistern. In this case, you'll see that that calculation doesn't have any red because that would be from a black water system. So in this case, the project demand and supply on a monthly basis is balanced. We have more stormwater than we can use. So in this project, we were not using any potable water for makeup water. we were a balanced equation with the size of that tank. So this is what the calculation looks like overall. I can't get a pointer. My apologies for that. Or can I? Here we go. So on the left side, you'll see our sources. You'll see our sources here, which is rainwater and condensate, and our total volume. In this case, it's by month. We have the exact calculation by day, but as you can imagine, it's much, much longer. In this case, for this specific project, we had no gray water, cooling tower, or black water. So our total recycled water available per month is in here. Our total potable makeup water required was 0. That's from that previous graph I showed you. This is the toilet flushing volume per month, which is cheating a little bit because of the occupancy days are a little bit off there. And then you'll see that our overflow to sewer was 0. So we're not overflowing any of our, in this case, black water or gray water because we don't have it. This is how much we overflow to storm water. And this is how much of that reuse water, that collected water is consumed. So our full calculation looks something like this. It's a little grainy, I know. When we put it all together, so you can see where the flows are coming from and going to, what the water balance looks like, and then the values of that water balance. So for system applications, on the rainwater system itself, it starts like this. We're collecting stormwater from a roof surface or groundwater. Groundwater is actually a very good resource. We need to be careful with both of those in terms of the water quality. Be very careful in Washington, D.C. with groundwater, especially if you have iron ochre or any hint or whisper of that. You would like to not put that into your reclaim system. We like to collect from roof surfaces, regular roofs, not green roofs. We try not to collect from pavers or drive aisles, anything low in the building. We really want to avoid getting any oil, gas, salt, or sand. You see a host of buildings around DC that'll put salt on their sidewalks. We really don't want that in our gray water system, so we would try and avoid some of those drains. The cleanest and best thing we can do is collect from roofs, gutters, and downspouts. The very first thing you do with that storm water is you send it through a roof wash system. I'm going to show you that in 1 second. And from the discharge of that roof wash system, you go into your cistern or storage tank. This could be designed by the plumbing engineer. This could already have been designed and required by the civil engineer through that jurisdictional requirement. So you have a raw water storage tank. We have a treatment system, and the treatment system, the way we like to do it, or the way I suggest doing it, is to purchase and specify a packaged skid-mounted piece of equipment from a single manufacturer. It makes the integration and controls integration much, much easier to do. There are horror stories in Washington, D.C., if you worked on different buildings or projects around town, that have reclaim systems that don't work because they tried to do an assembly in a kit of parts from different resources and build their own controller and tell it what to do. My opinion is you're much better off buying a treatment package from a specific manufacturer that will take the treatment and the controllers all as an individual package. It controls water levels, it controls the flow, the pressure drop, when your filters backwash, etc. There's a host of manufacturers that do it, and we'll go through some of that. And then ultimately you have a pump system and a piping system. And the pump and piping is really for your distribution into your building. And again, I mentioned before the purple pipe and the caution harvested rainwater do not drink. And that's so on the piping, that's for the interconnection. So we don't connect the pantry sink in the future to our reclaimed water system. So in its simplest form, this is your reclaim system. So in this case, we're collecting from a gutter. We are going through a roof wash system here, or whoops, sorry. We are going through a roof wash. through a roof wash, we're collecting it as cistern. And in this case, the cistern is really just being used to irrigate the lawn. It looks like it's going back to the toilet as well. So there are older homes. We have a gentleman in our Chicago office that, I don't know if he still has this house, but he used to have a house that had 2 giant cisterns in the backyard and a pump that was just used for irrigation of his lawn. I'd imagine he had the best lawn in the neighborhood, is my guess. But so that's in its simplest form. But going back, and I'm going to show an engineering diagram here in a second. The first thing that we recommend, and in some jurisdictions it is required, is to install a roof wash diverter. So the roof wash diverter, the way this works is the initial flow of water from a roof, and it makes sense on days like today where it's going to be nice in Washington, D.C. for 4 or 5 days, and then it's going to rain. That initial wash off your roof is cleaning your roof. It's taking all sorts of things if you've ever been on a roof. It's taking debris, it's taking leaves, it's taking bird feathers, it's taking bird droppings, etc. A lot of those things are organics, and we really don't want those organics in our storage tank. So the idea here is that the water comes down and it washes through this initial roof diverter or roof wash system. The idea of this specific one on the right, there's a couple of different versions of it. This detail on the right actually happens to be from the Oregon Stormwater Harvest guidelines. The idea here is that you're limiting the output, you're limiting the outflow here. So in a heavy flow, the water would, in a low flow, you would lose all that water, a very low flow. Under heavy flow, this ball actually floats up and seals right here. It would float up and the rest of the water goes by and into your tank. This device on the left is also a diverter. It happens to be made by Optimax. Optimax makes roof diverters. You'll see on this one where there is 2 outfalls from this. There's an inlet in the back, an outlet here, and an outlet on the bottom. You'll see this connection on the top. That's for a water connection. So what's happening with this one, this is actually a screening device. It has a screen similar to this filter screen, and it's actually screening out the water as it's going through. And then what happens is at a specific interval, this water connection will actually spray off the filter and it will discharge here to the overflow connection, which is a pretty cool device. And there's different ones out there, but the idea is that, and there's more primitive ones, there's more complicated ones, but the idea is you want to have that initial filter for the stormwater management. One stormwater device we've used in the past, this is going back quite some time, is we actually used a bay saver device, which is a cyclone device, where back before you had to do detention, you had to do water quality. So Storm Scepter makes one. It's a much more sophisticated version of this. I would recommend the Storm Scepter one for a much larger volume system. Smaller volume systems, you could use this. The one on the right is probably for a much smaller system. I would consider the one on the right more for single family home or light commercial. So this is a system that's installed currently. This happens to be at the American Geophysical Union project. And what you see, this is actually a glass door. You'll see the Rubendian number here on the right. What you don't see is on the left side of this is that concrete stormwater tank. It's already in the tank now. It's gone through its initial roof diverter. And this is the simplicity of the system. It's a very small room. I would recommend we do a bigger room next time. So work with your architect friends and try and get a slightly bigger room if you can. Although it's perfectly serviceable, we just can't get a good photograph of it for a presentation because it's a little narrow. So it's not made up of very much. There's a clean water tank here, a control panel here, and your water treatment system here on the right. So the idea is that we're taking the raw water out of the storm tank. It's going through the treatment system, and it's filling up our clean water tank. And then we have distribution pump right here you can see behind, and the reclaimed water is distributed from there. It's actually pretty simple. There's a lot of stainless steel in this room, but it's really the system itself once you're past the stormwater detention, is really treatment, storage, and distribution. So this is a different diagram. Apologies, I always hate, even as an engineer, I hate putting drawings in a presentation, but I'm going to walk you through it anyway. So in this case, in the upper left corner is our raw water storage tank. You'll see our raw water feed. It's already gone through. In this case, it has already gone through our diverter. And this is our raw water tank here. The water is then taken from this tank. We have controls in here, which is float assemblies. The float assemblies, number one, tell us there's water in the tank, so we don't turn this pump on and turn the treatment on if the tank were empty. The other float switch is actually letting us know that there is not any water and we actually need to use city water. We go through a pump. This package here at the bottom, including the UV light, all of this down here is that package system I mentioned. This is what you would specify and buy, this entire piece here. This is the treatment system of the package. It has filters. It has our typical design for that treatment system is going to be a multimedia filter, a charcoal filter, a UV light, chlorine injection, and a dye injection system. And in some cases, and it depends on your jurisdiction, a calcite filter. And the reason you may need a calcite filter is to decrease the pH of the water. So technically, if you read the discharge guidelines for sanitary systems, doesn't quite apply in Washington, D.C. because you're a combined system, but it applies in other places. Technically, your discharge permit for sanitary, you're limited in how much pH or what the acidic level of your sanitary discharge can be. So legally, orange juice exceeds the limits of that pH level normally. So does acid rain. So everybody remembers the term if you're old like me. We used to talk about acid rain all the time for a long time. Where that's coming from is in the urban setting, when the storm water is coming down, it's taking the pollutants out of the air, namely combustion from cars mostly, and it's trapping it in those water and it's bringing it into your tank. So sometimes your pH levels in your stormwater is going to be a little bit too high. Many times I think that's overlooked, but what I'd probably recommend is at least putting a spool or a space in order to put a calcite filter in to reduce the pH if the jurisdiction requires it. So this is your package skid. Ultimately, we are going through a UV light. Everybody knows these days with COVID, there's a lot of discussions on UV lights lately and their ability to disinfect. This is a sealed system, so all of the water is flowing here and being disinfected. This is our filters over here are really taking out, multimedia is taking out solids. Our carbon filter, our charcoal filter, is really trying to take out color and make it as clear as we can. The downside of a charcoal filter or a carbon filter is they actually would filter out chlorine as well. So when that filter filters out chlorine, that's why we have a chlorine injection system. And then ultimately we're going through a UV light in case there's any organics left, any viruses left, anything left in the system, the UV light will kill it. And then ultimately we're up here in a treated storage water tank. What we like to do with our systems, this isn't every system, it's really going to depend on your application and what your throughput is. If you have a lot of throughput in your building, then you may not need this piece, but this piece is a clean water recirculating pump. And what this piece does is it continuously circulates between the UV light and the storage tank. So when this treatment system is off, your storage tank is constantly recirculated and constantly being sent through the UV light. It's just basically belts and suspenders to make sure that we're killing anything that may have grown in this tank, any organic that may have gotten through our system. The reason we go this way, off to the side, is as I mentioned, if we recirculated it through this full system, the carbon filter or that charcoal filter would take the chlorine back out. So any chlorine we put in would be taken back out and then we would put it in again. So that's why we bypass most of this system, and we're really just trying to maintain the disinfection through the UV light. And then we have the distribution pumps, and the distribution pumps go out to the system. And in this case, we're flushing fixtures and we're going to a cooling tower. The hydropneumatic tank, this has to do with the booster pump. This could also be part of this skid. And then we have, let's see what else. That's it for that one. So this is that installed system again that I've already shown you. So I'm going to skip that slide. This is a project that was done by our office in Portland. This reduced the potable water use by 60% by capturing and reusing stormwater. And the stormwater was reused for plumbing fixtures as well as cooling towers. And in this case, the cost of this building with the Edith Green building was really mitigated, where they were lucky and creative at the same time, where they repurposed a rifle range that was below the building that was no longer needed. This building was a gut modernization. They repurposed a gun range or a rifle range, sealed it up, and used it as their stormwater vault, which I thought was pretty brilliant. This is a very cool project out in Portland. This happens to be the metrics of what we were talking about, or what they were able to do. They were looking at their water usage, how much they saved with just low flow fixtures alone, and in this case it was about 33%. And then with the rainwater capture, they were able to gather that additional sort of 27% in energy in water savings. This is the San Ysidro land port of entry project. Similar, where this would have been a conventional system. In this project, they did efficient irrigation, low flow fixtures, condensate recovery, and then ultimately were able to do a stormwater harvest and cistern, which was able to save them a substantial amount of money based on how much water they consume. In this case, they added a gray water system. I put that in there only because the gray water system is the process for the gray water, the design process is similar. The real difference on the gray water system is, instead of buying a packaged stormwater system from Burke Process, let's say, they make a pretty good product. You would buy a membrane bioreactor system, and that could come from somebody like Hooper. But the flow diagram is nearly identical. It's just how you treat the water and to what level. It's just slightly different. And then ultimately, this had off-site water recycling as well. I want to remind everybody that we don't want to rely on stormwater management, capture, and reuse solely. We still want to do a lot of water efficiency. We still want to select proper fixtures, low flow fixtures, water reduction fixtures. These days we're getting 35 to 40% over LEED version 4 by selecting proper fixtures. There's some great fixtures out there in that water closets, for example, that are now 1.1 gallons per flush, even better than the 1.2. Urinals now, we're actually even better than this now. We're at 0.125. And you'll see, although I wouldn't go too much lower than with the rest of those values, but we still want to be very conscious of our water consumption, even though we're using stormwater reclaim. I wouldn't want to see us do a stormwater reclaim system and then say, oh, because we have stormwater, our water closets should be 1.6. I still think we want to be conscious of that and reduce as much as possible. So some summary slides here, and it's really some do's and don'ts. That the harvested rainwater supply, this is the treated water supply, is completely separate from potable water. We want to make sure we identify it and that it's clearly labeled with purple tape and purple markings. And this many times is a requirement, again, by the jurisdiction or by code. In every room using rainwater, and this is going to sound bad, you're going to have to let your building inhabitants know that you're using recycled water and that it's being harvested to flush fixtures. In many jurisdictions, this is a requirement. So keep an eye on that. Work with your architect and your signage folks. This is generally something that if you're using stormwater reclaim, you will need to do. In the equipment room, you want to know and make sure that people are very aware of what the system is, especially if the system's not working right. We want to make sure they know that this is not a pure water system. This is not a reverse osmosis system like you might see in a hospital. I mean, this is taking raw, untreated, non-potable water and making it okay to use for non-potable uses. So we want to make sure that that's identified in the room itself. Again, we want to label them that they're not safe to drink. This happens to be from Oregon. That the makeup water is supplied automatically from the potable water supply. There are ways to do it. We typically do that makeup water supply in the treated water tank through an air gap fitting. That way we are guaranteed that there's no cross connection ever between our potable water and our non-potable water. There are absolutely ways to do it in certain jurisdictions that will allow you to connect the two systems together through backflow preventers and hard pipe them through backflow preventers. Virginia is one of those places that does allow you to do that. I'm always a little more comfortable with an air gap fitting versus a RPZ, but you'll see here in Oregon, they allow you to do both as well. So this is just part of the calculations. This is making sure that within our spreadsheet, we're able to change the size of the storage tank to determine the optimum sizing. In other words, I know there's a system in Virginia right now where someone put in a 300,000 gallon storage tank for a school. The issue with that is they won't even use 300,000 gallons of water to flush fixtures in a year. So the issue there is the tank is so big that the water level is constantly very, very shallow. And even when they have a little bit of water, they can't get it out. They can't get that water because the pipe of connection is 6 inches above the bottom. So the first 6 inches of water they store in this gigantic tank is not usable. So we want to be careful about oversizing tanks. And the other thing is, if you look at it on an annual basis, you might have ended up with 300,000. If you look at it daily or monthly, I'll bet you that tank could have been 15,000 or less. And then your tank is full, and then you have access to that water when you have tanks that are full versus having 6 inches of water in them. So that's for that one. That slide wasn't supposed to be there, so I'll skip that. So some of the do's and don'ts, just some lessons learned, a couple of things. Provide a low point sump in the raw water storage tank, either with a connection to that low point sump, or you could do a submersible pump in the tank itself. This is so that you can empty your stormwater tank for maintenance if you ever need it to, or sanitization if you ever needed to. Provide side stream circulation pump with UV light. I showed you that in the diagram that we have. Provide access to the storage tank for inspection and cleaning. Provide a light in the storage tank for inspection and cleaning. Ideally, you would do this. A lot of times we don't, but I think in an ideal world, you'd be able to turn a switch, the lights would come on, and you're able to inspect the water in that tank to see if there's anything happening, anything going on. Most of our designs, I didn't show it in that flow diagram, but the way our designs always work is we have a gravity bypass around the main storage tank. So if anything were to go wrong with our system and we had to shut it down for any way, shape, or form, we can shut down the connection to the raw water tank and it will flow around that tank by gravity. So and the other thing would be any human error would not rely on any pumps at all. So that's another do. I did not put that here, but I should have. One of the do's is make sure we have a control system that's integrated with all of the float switches and booster pumps. So again, that package system from Burt Process will do most of those things for you. We just have to specify it to know that they need to provide the controls in the raw water tank, and they need to provide the controls in the treated water tank as well. So all those things can work together. As far as filters, we want to make sure we have an electronic alarm to indicate when the filters are full. This is the multimedia filter, charcoal filter that I mentioned. Many times if you specify and purchase a package system, it's based on differential pressure, and those items will backwash automatically. That would be my recommendation. However, if you don't have it backwashing automatically, certainly put it on an alarm so that people know when they're reminded. It's not quite like people's swimming pools where they generally remember to backwash at whatever interval because it's in their backyard. These systems tend to be down in parking garages and basements and are easily forgotten. So we would like that connected to the alarm. And then the last one would be, to consider chlorinization injection to address odors or issues from the harvested water. In DC, we almost always do chlorine injection. And the other thing we do is dye injection as well. So we are dyeing the water blue, generally speaking. Blue dye number 2 comes in a 55-gallon drum with a dosing pump. It's based on the flow of the water, and we're dyeing that water blue. Couple reasons for that. We're protecting ourselves again from cross connection in the building. If you connected a drinking fountain to this system, the water will come out blue, and you'll know you've connected to the wrong pipe. The other thing is sometimes the reclaim systems tend to be tinted. So it's not crystal clear water all of the time, despite all of the filtration efforts. So the other reason we'd like to put a little bit of blue tint in there so that the water comes in blue and it looks like the old Tidy Bowl commercial. So the water that's sitting in the bowl is actually tinted blue instead of tinted tea color. One thing we don't like to do, again, is collect stormwater from green roofs or paved surfaces where your vehicle can be. And the reason for that is, again, we're trying to keep organics out of our raw water storage tank, and we're trying to keep oil and gas out of our raw water storage tank. You can absolutely do it. You can connect those systems, but there's an additional treatment you would need to do. You would have to put an oil water separator in front of either your storage tank or in front of either your treatment system in order to remove both of those items. So it's possible to do. It's a different application for sure to remove those two elements. If you had a massive parking lot and decided you wanted to do a reclaim system, it's probably a good idea, but you absolutely have to do those interceptors in front of this system in order to keep those things out of your storage tank. Your other don't is do not drink the rainwater. So this happens to be from one of our projects in Hawaii, and they had to put this sign by code to tell people not to drink out of the toilet. I think that should be obvious, but apparently it's not. So don't drink out of toilets. That's my last don't for the day. I'd like to, that's the end of the presentation. If you've got questions, you can type them into the chat on the lower right. In 2 weeks' time, Scott McCucci in our office, a licensed engineer and lighting designer in our office, who's been with Interface for quite some time, is doing an introduction to lighting. So that'll be in 2 weeks. You'll get that invitation in about a week or so, and that presentation will be in a couple of weeks. So we would encourage you all to attend that one. That'll be a good one as well. And then we're at questions. Are there any questions? Let's see here. Someone put irrigation question mark. Oh, now I'm seeing all of the, my apologies about the slides. Now I'm seeing all the notes about the slides. Somebody put irrigation, of course, we could absolutely use it for irrigation. I think that the project we were talking about, we did not use irrigation. The project didn't have irrigation, but absolutely, that's one of the main uses of the reclaim system, especially if we're collecting condensate and stormwater, which would be, condensate is going to be actually cleaner water than stormwater because of that acid rain thing I mentioned, but absolutely we could use it for irrigation. I'm stuck on the first slide. What do I do to get the AIA credit for this webinar? I need Emily's help on that. We're going to send it to you. If when you signed up, you clicked and said you wanted it, you will get it. If not, you could email myself or Emily your AIA number, and we absolutely can get you credit for this. Someone's asking about a template for rainwater harvesting. And I assume you mean a calculation. I'm not sure. I have not researched that in terms of if there's a commercially available calculator. Our calculator as interface has been homegrown for quite some time. Different folks have done different work over the years, and we've combined them all into both that graphic and that calculator. So I'm not sure if there's a commercially available one that you could buy. Sorry, I just don't know that answer. What we will do is we'll post and publish all of these questions and answers in the next week or so. We'll combine them all. If you have additional questions, you're certainly welcome to send them in, and we'll get those answered, kind of like a Q&A, and we'll publish those answers back to everyone that attended today. Somebody put, we are looking into writing our own university's building standards in a CSI spec section. Yeah, for sure. There is a CSI spec section for rainwater harvesting systems out there. Spec Link, Specs and Tech, Master Spec all have that section. I think it's a great thing to put into play in a university setting, and have a standard where you get to make the decision on a handful of the points I mentioned today. Whether you want to recirc through the UV, whether you want a calcite filter, whether you want to dye the water, et cetera. There's a handful of decisions that you could just make once and for all, and publish them as part of your standards. I think that would be a really cool idea. Okay. Somebody wrote, in a water challenged area, what other additional procedures to reclaim site stormwater for reuse? One of the things we've done on other projects, we have a project for the World Bank in Africa where it only rains about 10 weeks a year in the location we are in. So for those 10 weeks a year, we absolutely reclaim the stormwater in the same way I explained, and we treat it and reuse it. For the remainder of the year, we actually are capturing gray water and black water from the building, and we are reusing and treating that water through a membrane bioreactor, and we're using that water for irrigation of our landscape for the other essentially 9 months of the year. So you definitely have to get a little more creative on where you're getting your water from when you have those items. Okay. All right. So there's a couple more questions here. I can't quite see them on my screen here, but I will get you, we'll print them all. Again, we'll print them all, answer them, get them out to you in the next week. Those that did sign up for the AIA, we'll get you those certificates in the next week. If you can't remember if you signed up or not, just shoot an email to myself or Emily at Interface, and we can get you that. And with that, it's 1:02. Thank you all for your time today. I hope you enjoyed it. Feel free to join all our future presentations. Thanks.
Thank you, Kevin. Great presentation. And thank you, everybody, and we'll see you next time.
See you next time. Thanks, Roger.